Mic test, mic test. Okay, good afternoon, students. The recording function of Google Meet is come back. So let me know if you have any problem. If no, then we can start our lecture. Okay, so today we'll go through chapter 3, and it's quite related to chapter 2. We already go through chapter 2 before Chinese New Year. So same thing is still based on the standard developed by the NCSFA. So since the standard is set, so it just continue to develop and see whether there is anything need to change or not. So previously we already have this let's say hierarchy, then we have this network, then a continuum model. Okay, so this part we already go through, and today we are trying to say this thing called data modeling. Okay, so the learning outcome for this part, you should know how to compare and contrast of this data model. Okay, why each of this data model need to be there, and of course you need to after study, you need to know what is the reason why it changed to the next data model. So we have a lot of data models set by this standard. From time to time, when it is not appropriate, then you will continue to do the changes. Okay, so of course for last maybe 20 to 30 years, the changes of this seems to be more common because more and more people join in to set the standard. Hopefully, the computer world or the IT world will be much more better. Okay, next one is to describe the concept in the conceptual modeling notation. We need to know all this conceptual modeling. What is the relationship between the first one and the second one? Okay, next one is to describe the main concept of this relational object oriented and a semi-structured data model. Okay, so this part is quite new. We said new compared to all others. A lot of this data model is already of more than 50 years, but this relational object oriented and semi-structured is about 10 to 20 years history. So this one is we say it's new compared to let's say HTML5 10 years ago. Until now, we still say that HTML5 is quite new. Okay, so this one is something we need to learn and is for our future. Okay, so for the first thing here, we have this thing called data modeling. And why we want to have this thing? Okay, data modeling are the first step in designing a database. So if you want to develop your own database, hopefully you already have your own topic and you already start this part because we need to have this data model by week 5. Okay, so the first step is designing the database data modeling. So which entity you want to put into your database, you need to think. And a lot of time when students come to this part, they always have problems. Okay, which one I should need to put into my database. So my experience is you just put everything in first, then after that just continue to remove and put in more in order to fulfill the requirements. So the process of creating a specific data model for an information system. So this database is to provide info to the user. So it's let's say information system. Last time when we start one course, we have an IT, we have an IS, we have a CS. So information system EIS, this one is considered as a new part for us at that time. Okay, so for providing an info to the user. Okay, so you need to create one model for them. Okay, which part you want to show to the user, which part you want to hide from the user. Not really need to show everything to the user. So and interactive and progressive process. So this one I think like what I said just now. For this data model, you need to keep improve. Anything that is missing, you put it in. Something that you think this one is not really needed, you just let it out first from your relationship linking. Then later you check again, see whether it really need or no. If no, then just remove it. So this one is continual development. So firstly we say improve to match the actual requirement. So you continue doing the improvement. So from now until week 5, you still have a 1 week plus for your submission. Okay, so next part, important of this data model. The data model can facilitate the interaction among the designer. So this part says interaction among the designer. So you are the designer, and of course same thing, you are the programmer as well. So and the end user. So you are actually you have a one group of students. So you cannot add as a different actor in this part. So some of the students may do their own data modeling. Then other students may just query why you want to put it in. Then you have a one discussion. So last time when I do this data model, we also have the same thing. Each of the students write your own data model. Then of course for the same topic. So after you finish, then you just show to other students. So other students will just debate discussion. Then why you want to put it in? Why this one should not be there? Why this one should be there? So you convince your other teammates. Then if others member accept, then of course you can put in this entity to your data model. Okay, so it is not only in the designer part of view, but sometimes you also need to think in the end user part of view. So which one the user will need to know? Okay, we already developed this data model. And for my user part of view, I am the user. So what is the thing that you want me to look at? And what's the thing that you do not want me to have a look? Okay, so in the point of a end user, of course, not only one type. So student maybe one actor, lecturer maybe one actor, or the one who key in the database, key in the info to the database, maybe as the end user as well. Okay, so this one is the first point. And I will say a picture is worth 1,000 words. So when you just write down the name, let's say student, enroll, and class, you're not really point out what is the relationship between all this. So you may need to continue write something attribute and write the relationship. What is the relationship between each entity? Then you can convince your friend. The relationship is like this. So student is enrolled into one class, so enroll as one entity as well. So previously we have this entity called with entity. It is an action also as an entity as well. Okay, so based on this picture, you convince your friend, see whether they accept your suggestion or not. Okay, so a well-developed data model can foster improvement and improve understanding of the organization. So based on this picture, we will have a better idea what is this database all about, and which part later we may need to do some improvement, or which part seems like missing some point, or how we're going to show more of this to the user. Okay, give an overview, overall view of the database. So before you actually go to develop your database, okay, this is the thing that you need to prepare. Okay, so if you already start develop your database, a lot of this row and a column, then only you discover some of the entity is missing. Then at the time you need to change a lot. Okay, so based on our assignment, we know we not only have 1 to 2 samples, but we may have a lot of samples. So let's say 6 times 20, or then maybe 120 samples of this entry we need to key in. Okay, so up to this part, you should pay more attention how this data model should be developed. Okay, organize the data for the various users. So this one we already mentioned which part of the data you want the user to know when they access your database, which part that you want to let them have a look, see, assess anything that you want to let them have any changes or what. Okay, and abstraction for the creation of a good database. So this one is the first part. So it's the abstraction for creating a good database. So before you actually go to develop your database, this is the thing that you need to complete first. After that, we already mentioned, we always in the improvement piece. So I got no doubt you will still after next week you will still most of you will still need to keep changing this data model. Okay, so data model is a collection of a concept for describing. So describing what you want to describe. So describe the structure, describe the attribute, the manipulative part. So the operation and the integrity of this rule. So you can see from the picture here, we define. Okay, this one is the branch table. Then for the branch table, we have this attribute. So this one is the manipulative of the part. Then the integrity, which one? What is the number? The branch number? It must be only for varchar. Okay, varchar number of this varchar is 4. So you can only key in 4 characters here. Okay, so this one is the starting of setting this integrity rule. So each of this, see, let's say for post, the postcode for this part is a little bit we does not follow our number here. So let's say for Malaysia, we only have a 5 digit of a number. So it represents all the places. Let's say Ipoh is some part of the Ipoh is 31000, some is 31500. Okay, so the integrity we can use this to do the checking, see whether the data key in by the user is correct. So during this data modeling, we already have a basic idea how we can say we already set it, but we have a basic idea which part we need to set. Okay, so continue to this part. Okay, so this one is the big picture that we need to know. We say we continue on do the improvement after the ANSYS standard come out. So it's setting, let's say from 1960, it have this hierarchical data model. Okay, continue from that part. Then we can see after let's say 10 years, it will continue on develop new one. Then since it becomes standard, it is a hardly change. Okay, I say hardly change. After let's say we set HTML5 as a standard, all of the students, all of the programmer already start learning this. It is hardly for them to change again during a very short time. So you can see we have this part here. From time to time, it keeps changing. So let's say from 1960 until now, 2020, the changes not much. 4, 5. Only 5, okay, 4 to 5 changes. Of course, some after change, it have you have 1 to 2 years, then they change to another. Let's say from network change to relational. Okay, the changes is quite fast. But from that time until now, this entity relationship data model is still there. So until now, we still are learning this part. So later we'll go through all this, and a lot of times we always for learning, we always answer this question. Since we already have this relational, why we want to have entity relational? We already have this object oriented. Why you want to come up new thing called extended relational? Okay, so this may be something that we need to know, and we know the disadvantage of one standard. Then try to develop the new one. Of course, the last one here we have this no SQL. This part is too big, and until now we only attach very little. Okay, from 2009 until now, only I think 2 to 3 years I heard of this thing. Okay, so in some of this movie. Okay, so this one is the history, or what we say cannot say history, but the standard that's set by ANSYS. Okay, so we repeat this thing again. Lastly, we already covered this part, the standard set by this ANSYS. So based on this, we have this external view, we have this conceptual view, and the physical. Okay, so we can see a better picture. How this one is why I say better picture from end user point of view. How you can see this database. Okay, which part you can look at, and a lot of times people always say you actually see the same database, but the thing that you see is somehow different. Okay, whether you have the right to view the data or not, or whether you have the right to change the data or not. Okay, so this one is the external view. Then the conceptual model, internal model, and the physical model, it does change a bit. It's still a logical independent and a physical independent. Last week we already mentioned, and you can see some of the parts here. Same thing. This one last week we already go through. For the external view is based on the end user point of view. The conceptual is what data to be stored. Okay, what data to be stored. And then the last part here for the internal one is how data is stored. So last week we already mentioned. So what data to be stored is the whole data. Then the internal part is where you want to save it. Okay, where you want to save it. So based on this part, we just jump. This one is already covered. Okay, so 3 phases of this database: conceptual, logical, physical. And that's why we repeat this from last week until now. We still have 3 to 4 slides. So you better have an idea how you can draw this out and give an explanation of what is the difference between these 3 designs. Okay, so after we already know the standards, we have this conceptual, we have this logical and physical. Then we come to this part. It is built from I can say from the top of this standard. So we already have this standard. Then we continue to develop our this entity relationship model. Okay, so the data model is built above of this standard. And based on the standard, so we continue to do the development. Okay, so an entity is a distinguishable object, that's it. So not only physical object, but a lot of time all this entity is not physical. So let's say we say paper, we say shipment. This one is not really a real person or a real representation. Okay, so but we just try to use it as an entity. Then later we can use it to build our database. Okay, so a person, a place, an item, and an event, all concept in the user environment. So you can see from here, it's like everything. If it can fit to your database and the action or the relationship is actually there, and you can put it in. Okay, so this one is the thing. I think is the part that is difficult, and how you're going to represent it. Okay, so let's say we have this order, and customer order product. So this how we going to write the name of this, and how we going to describe it. Okay, what is the action or attribute that are actually put inside here. We actually didn't have the actual let's say invoice to look at. So that's why it is somehow difficult for us to develop this. So that's why we say this entity relationship is the work of all designer, programmer, and the end user point. So you may need to consult some of the senior or some of your friends who already work in the real world. Say, okay, can you send me some sample of this order form or this invoice? Then you know what is the thing that actually need to put in. So this one is the entity. Okay, so we have all this. Then it's about the organization wish to maintain data. So we need to have all this. So only we can key in something to the database. If without order, then how are we going to know which product actually order? But for the order part, inside which attribute we need to put in. So let's say date, who is the one who order, which product they want to order, what is the quantity, what is the price. Okay, so whether you need to put all this in or the order or not. So this one is the thing that we need to learn. Okay, so after we know this, then only we can develop this ER model. Okay, so then only we can continue to develop our database. So each entity contains a set of attributes, and this attribute we need to write it down. Then of course the integrity needs to be there, and a relationship is an association among several entities. So you can see not only a one-to-one, one-to-many, but sometimes it have a lot of linking. So one entity may have more than one linking to other entity as well. Okay, so this one is the relationship. Okay, so we have some symbol here. Okay, we have some symbol here. So you hopefully I think that the last subject you should already know this. Then now you will be more familiar. Okay, so we have this strong entity. We have the weak entity, and we also have this associative entity. It is not only an entity, but it also a special relationship between the two entities. Okay, so this one is the entity part, and then for the attribute, we will have a lot of this data inside. Okay, so attribute. Then for the relationship part, we say we have this relationship degree. Not only a unary, binary, we also have this summary. So this one is how many relationship between others entity. Okay. We also have this relationship of cardinality. So you have one to many, many to one optional, one to many optional, one to many to one. Okay, so this one is the relationship between entity and the symbols that you need to use when you develop this ER diagram. Okay, so after we have an introduction to this part, then we come back to the history. So the early data model. So this one we already mentioned for this NC. When they develop or set the standard, the starting is hierarchical. Then I'll come to network, then relational. Okay, so we need to go through this. So we have a basic idea of what is this hierarchical model, network model. Then why you need to change. Okay, so why you need to change to the new one. Okay, normally if one standard is perfect, we do not need to change. Okay, so this one is our idea or our rule to follow. But if something not follow the actual requirement, and we have the ability to do the changes, then we will try to change it. So we take this let's say Wi-Fi standard as sample example. So previously we have a Wi-Fi 4, Wi-Fi 5, and now we have this Wi-Fi 6, and the speed will be much more faster. Okay, so if you have this fiber nation, if your house have this fiber, then you can discover if you change it to Wi-Fi 6, the coverage will be bigger and the speed will be faster. Okay, although for most of us, if you already have a fiber, then it's good enough. But a lot of times, if one company have let's say 100 of workers, actually the speed to share amongst all the workers, let's say Wi-Fi 6 is just good enough. Okay, so this one is based on the current if you change it to Wi-Fi 6, the coverage will be bigger and the speed will be faster. Okay. Although for most of us, if we already have a fiber, then it's good enough. But a lot of times, if one company have let's say 100 of workers, actually the speed to share among all the workers, let's say Wi-Fi 6, is just good enough. Okay, so this one is based on the current situation. Then maybe they need to do the changes. Same thing now for our 4G, 5G, or even a 6G. So the reason why they want to change it because a lot of this limitation, disadvantage, they continue to try to improve. And if the technology for us, if the technology is good enough, capable of doing all this, then of course we try to change it. Okay, so this one is the idea. Same thing for this hierarchical model. So that time then okay, this one is the first one, the first model that we have, the early data model. So hierarchical model is represented by an upside down tree, or normally I used to call it a pyramid. Okay, not only from the top to bottom, it tries to be leveled down. Okay, the relationship between the top and the bottom is this child model. Okay, so this one is the relationship between the child and the root and the child. Okay, so you can see from here, we have this root statement here, and continue, we have a component A, B, C. So each of these may or may not have a child, but if I have, then it may have more than one. Okay, it is possible that it may have more than one. So let's say for C component C have this assembly B and C. Okay, and for assembly B may have a B, C, D, E. Okay, so the level, it contains the level and the segment. Okay, so this is the idea, the relation, the model is upside down tree, and there is a relationship between each of these level or segment. So it may be, sorry, it may have a one to many relationship. So we have a one to many relationship between the root and the parent and the child. Okay, so this one is the idea, the earliest one, and it may have some limitation. Say, what is the limitation? Then come to this part. We suggest this standard N6 standard suggested the new one, which is called network model. Then I can see it could represent a complex data relationship. So we know during the 1960 or 1970, the computer, people who know computer, not much. But if you have one computer and you want to develop one database, at the time it seems like you don't have much choice, but you can develop your own one. Okay, so by that time, if people thinking about this complexity of data input, what is the relationship between, let's say, invoice, credit, debit, the salesman and the customer? It seems like for that time, it is too complex. Okay, too difficult. But it needs to have an improvement. Then only the world will become better. Okay, so that time for the hierarchical, you think that this one is not really hierarchical based. Okay, if for one family, yes, family, we have a grandfather, grandparents, grandparents, and then child. Of course, this one is a hierarchical based. But for the real world, the relationship between you and me and let's say other friends, it seems like not a hierarchical based. So this is a new thing called network model come up, and it represents this complex data relationship. We didn't have any top-down relationship, but since we joined to TAUC, then we become friends or lecturer and a student. So this one is a kind of relationship, but it's quite it's not that tight. Okay, so we are not a top-down part. Okay, great to represent a complex data relationship. It can be the network model. It can be more effectively compared to the hierarchical model. So it can use it to improve the database performance and to improve the database standard. So we know after we change it, it reflects the real world. There is a relationship between one another. So let's say the sales representation and the customer, they have one relationship based on the invoice. Okay, so this one is after they come up with a network model, they can build one model like this. So it supports many to many relationships. So you can see from here, this part for the hierarchical, it only have one. Here, it should be here, one to many, but not many to many. Okay, so this one is the difference. So for the network model, it actually supports this many to many relationship. Okay, so based on these two models, we combine and say the limitation of these two models. The first, for this part, the data flow is still what we call rigid. So this one is quite fixed, quite fixed. You already have this model, then the data key in, then it's key into the table. Then when it have any relationship with other, it seems like it hardly can link each other together. Okay, so this one, we didn't have the real example here, but we just say it's quite rigid, quite fixed. We cannot change too much compared to the later one that we want to introduce. Okay, so this one is the reason why it wants to change for the first one. And the second one is that there's no data defines language access. So when you want to develop the database, there's no such thing. Who can access this, who cannot, who is the user or who is the owner of it, there's no such thing. So changing the structure of the data somehow is very difficult. Okay, so although we already have the standard, but in order to continue or develop, we still face some difficulty. Okay, so okay, next, a simple query language. So previously in our Oracle, we just simply type, right? We select something from the table, then we try to order what is the order that we're going to show. Okay, so we can have this simple query language, do some searching. But at that time, during this network model, there's no such thing. Okay, so it all based on the application. So the application will need to provide and show the data to the user. Okay, so the next one that will come out is the relational. So you can see from here, relational is from the early relational, it's from 1976 until now. So it's more than 40 years. Okay, so data and relationship represents a collection of a table. So this one is quite mixed to what we will do later in our assignment. each of the table have a number of column and a unique name. So you can see we have this entity branch. Then each of the table here have the number of columns. So column, the name is unique. You cannot have a same name of this column. The degree in the number of this attribute is the relationship. So how long of this data you want to continue develop or key in, then this one is the relation. So it point. Okay, it seems like there's no such thing here. It seems like you can point a relationship between this table and another table based on the branch number. So during our practical tool, we have a sample. The mechanic. Okay, the mechanic is work in a which branch. Okay, so this one is the relation. Then the next one here we have a cardinality. So this is the number of attributes in the relation. Okay, so same thing. Let's go through this. Okay, so user seems this is a DB as a collection of a table. So if we want to print it out, we can print it out as a table form, right? So example is when you learn let's say FS. Previously, when we learn Office, we have one special one SS. Then when we do the printing, most of the time we print it as a table. So this one is to demonstrate to the marker which data will be keyed in. Okay, each of the table is independent from another. Is it independent? Sometimes it's still dependent. We have this foreign key here. Okay, so there is no we key in something to branch. We do not need to bother too much about others. It may have relationship, it may not have a relationship, but sometimes if we have this foreign key here, then we need to have this integrity checking. Okay, I wrote in a different table are related based on a common value in this common attribute. So this one is a common attribute. We have this branch number here. So this one is the common attribute. So we can see we have this B005. The branch number B005 is in the city of London. So John White is in charge in the branch number B005. So this guy is actually work in the city of London. Okay, so we can based on this table have the relationship pointing and explain what is the relationship between one table and another, although it is independent. Okay, so a relational model here we have this integrity constraint. Okay, last week we already mentioned if we want to create one table using DDL, we can just try to set we have this some setting here to check the value. We check do the primary key, foreign key. So if we already set primary key, foreign key, then when we key in data, then we need to pay attention or check whether this foreign key is actually active in another table or not. Okay, so this one we need to have the relationship. We need to pay attention check again for the referential integrity. Some other this domain integrity have this primary key. Not now. You must key in something to this field. Otherwise, you will not let you continue. Okay, so this one is for the primary key. Not now. Then we also have this check between one number and which number. So this one is the restriction of this field. Okay, for your mark, it should be from 0 until 100. Cannot be less than 0. Cannot be more than 100. Okay, so this one is the integrity checking. All those I always afraid 69 and 59. Sometimes for those the handwriting is not so good. If I see some kind of this number, I always need to check again see whether my input is correct or not. Okay, so 59 and 69. Some of the student or some of the lecturer writing seems like quite similar. Okay, so you need to pay attention this part for the integrity checking. Okay, next one here is wow, so fast. It seems like I can end a little bit earlier. Okay. Okay, so we already have finished this relational model, and this is the thing that you need to do for this week, and hopefully next week you can submit a complete and no mistake or not need to change EI diagram. Okay, so we finish this part, then I'll continue to the next one. We have this thing called object-oriented model. Okay. Object is an abstraction of a real-world entity. So that's how we already mentioned. When we develop this EI diagram, not all the entities actually exist in the world. We can just use something like order, purchase, patient name, patient list in order to make this EI diagram or our database more have a complete function. Okay, so this one is the idea of using this EI diagram. Then I come to this object-oriented. When we say this object is an abstraction of a real-world entity, abstraction it means not really real. Okay, I can use this word. Abstraction is to say not really real thing, but is just an idea. If we have this thing in our real world, we can use it. Okay, so it's quite similar to what we just now mentioned. You can use a purchase, you can use an order, you can use a patient list or whatever. Okay, so if you have this thing in your mind, then you can put it in the model. And of course, it must have its own objective of having this thing put inside your EI diagram. Okay, and object include information. So if you, I think all of you should already go through the OOP object-oriented programming class. So an object includes information about this attribute, the status, and of course the operation. Okay, so one is the noun, one is the verb. So based on these two, you can try to use it in the database as well. Okay, so this one is object-oriented. The attribute describes the property of this object, and the behavior or operation specifies how object acts and react. Okay, so for the property part, you can see we have this for student. We actually have the name, date of birth, year, address, phone, etc. If you need this info in your database, then you can continue. Okay, continue. So but this part must belong to student. Okay, so this one is something that attribute that need to put inside student. we also have this behavior or any of this operation. We can continue to calculate each. And you can see here, right, date of birth and a year. It's quite similar, right? Yes, it's quite similar. But whether it's suitable or not, you judge lah. You judge. It seems like duplicate already. Okay, so for we already know the date of birth, then of course we can always do the calculation of the age. And of course, if we already have this course and we know all the results, we can calculate the GPA. Okay, then we also have the registration for the course. So this is something we try. Okay, we try to list it down. Whether it's suitable or not, I cannot say now. Okay, so this one is the idea, the basic idea of what students will do. Have the relationship to the course in let's say in one college or in one university, and they need to decide which course that they want to enroll. Objects that are share a similar characteristic are grouped in one class. So for object-oriented model, we always say, okay, you are the same class if you have the same characteristic. So for students, if you already enroll to one course, I can say you are the student. Okay, so this one is based on your characteristic, then you are in the one class. Yeah. Okay, so this one is the object-oriented model. It seems like you go back to the OOP class, right? Okay, so classes are organized in the class hierarchy. So you come back to hierarchy again. Okay, so we can see from here, for example, this one is the example again. Employees, and we have two kind of employee. One is a commission employee, one is clerk. So commission employee, it didn't have any overtime. It wouldn't have any overtime hours, overtime rate, and allowance as well. It's only based on the sales. Okay, although they are both employee of one company. Okay, so you can see they have one common part here, which is the basic salary. Although they get the same basic salary, but they actually are different. So the commission employee is based on their sales and calculate the commission. Whereas the clerk, they only get basic salary, and sometimes they have some overtime. So let's say they work after working hours, after 5 o'clock, after 6 o'clock, they can claim this overtime. Okay, so based on the difference between these two, we can just divide it to two others. Okay, so that's how we have this student. Then maybe we can also divide this into two. One is full time, one is part time. Okay, then this one is the use of object-oriented model. Okay, so inheritance object inherit method and attribute of the parent class. So this commission employee actually inherit all the method and all the attribute from the parent class here. So anything that exists here, this commission employee will have. But for the employee, the normal employee, some may have commission, some may not have. Okay, so to differentiate, to differentiate. And then I'll continue to this part. We have this object-oriented model, the relationship. Okay, so this time we try to write down the attribute and the method of one entity. For this part, we try to link one entity to another. Okay, so if I'm not mistaken, you should, sorry. This UML is normally used to develop object-oriented model. So I don't know whether you learned it before or not in your OOP. But last time I actually learned it, but the program that developed this UML somehow is not complete yet, and it always crash. Okay, so we have this object-oriented model, the aggregation and the composition. So we always mention this. Student. Wait, okay. Okay, so this one is the relationship between two entities. This is a student. All the students have name. Okay, all the students have name, and all the students also have an address. They stay in some place. Stay in some place. So you can see all the students have name, and it's one-to-one. So it won't be duplicate. Okay, so this one is my solution. My way of explanation. Okay, so it's one-to-one. So it is composition. Based on the name, we use it to differentiate which student is it. Okay, so this one is based on composition. The next one here we have this student and address. But for this address, it actually have more than one student stay in this place. So it is 1 to 3. Okay, so it means in this house, actually stay 3 students. Okay, so when you come back to compound, then a lot of students actually stay together. And this one is the case. You register to the school saying that you stay in this address, and this address actually have more than, let's say sometimes it's more than 10 students stay in the same place. Okay, so my case previously I stay in one landlord house. The house have the address have 2 house, and it actually can stay more than nearly 18 students, and each one have a single room. Okay, so the house quite big. Okay, so based on this, then the system will record down one address and 18 students. Okay, so this one is the aggregation. They actually aggregate or combine. I cannot say combine, aggregate. Join, I can use the word join together. Okay, join together using one address. Okay, so this is the symbols that we use for the whole diamond. This one is the aggregation, and the black color is the diamond. This one is the composition. Okay, so this one is the basic relationship between one entity and another for this object-oriented model. You can see the relation, the sample is not that much. And we just simply patch this part. Okay, next one. Like what I said just now, for this object-oriented model, if you want to actually expert in this part, somehow you must learn how to use this UML, the Unified Modeling Language. So this one we use one program to list out all the entities, and we continue to link one entity to another, then continue showing that what is the relationship between one to another. Okay, so just now we have a list of one to one, then a 0 to 1, and the relationship between one and another. You may need to write it down. So you need to explain what is the relationship between this professor and the school. Okay, so this one is the relationship that you need to write down, rather than only use this ER diagram, which is only showing one to many, many to one. Of course, we still have a one simple 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 description of, let's say, pay to. Okay, pay to. Okay, so the difference here, I think mostly is the number. The relationship mostly is the number, one to one, one to many. The notation is not the same. Okay, so 4 o'clock, we have a 5-minute break. Before you go to break, please put a +1 now. Put a +1, student. Okay, then we have a 5-minute break. Come back by 6 past 4. We continue to this part. Since we already introduced the OO, then we will always mention why this OO is better than all other language. Seriously, when we have this, let's say Java, Python is also object oriented. So compared to C, when we say why you want to change it to OO, and a lot of this reason come up here. For the O1, sometimes it's inadequate. A lot of this function is actually hard to implement. Okay, so that's why we come up the new one, OO, and hopefully it will help to solve a lot of this transaction or to represent the real thing in the real world. Okay, so this one is their objective. Okay, so start from 1985, we come up with this new thing, object oriented. Then nearly used 10 years. Yeah, 10 years. And only we see this Java and some other object-oriented programming will come up. Okay, although it's already there, but a lot of this student or programmer, when they start learning this OO, it's actually start from 1990 somehow. Okay, somehow 1990. Okay, so for this question, why you want to use OO? The reason always comes here. This part. The conventional data model somehow inadequate, so it cannot really represent the real world. Okay, so cannot model complex data and some of the unstructured data. So this one is the idea. We normally try to list out all the data that you want to key into our database. Okay, so let's say when you want to order some part or some product, we know that we need to key in the date, the price, who is the seller, when it will reach this part. Okay, so normally we can key in all this, but sometimes we have something that is unstructured. So let's say we want to buy something, product A and product B. Product A and product B, it may not have the same description. What we say description. Let's say one is laptop, one is desktop. Although it is a computer, but the description that put in sometimes is also different. Okay, so that's why we say unstructured data. If we want to key in all this, then we need to do some changes to the database. Okay, so not only the description, but sometimes some field is not included in the database. So it cannot model the process. So a lot of this database. So until now, we still can check most of the database is recording all the field which is fixed. So let's say how many kg, etc. Okay, so but during the processing of this action or checking of this process, it actually didn't have the number or the system to key in all this. Okay, so this one is the reason why we want to change it to OO. Okay, we may have some example. So let's say if you want to go through some tests, the database may only record whether it's pass or fail, but sometimes you still need to key in from the starting what is the data, middle of the point, what's the data, or from each second what is the data that you actually process. Okay, so this one is the processing time, what and how much of this data is actually processed. So this one is what we call the dynamic behavior. It won't be possible to do this kind of recording or include this into the database. Okay, so this one is the problem of this OO. Okay, so another one is that it cannot model, it does not support reuse. Of course, for most of the database, until now we won't need any reuse, so it cannot support reuse. I also haven't found any example to tell you how we can do this reuse in this OO database. Okay, OO model is more natural. We know it's more natural. So we put this OO into the real world. We try to model it, then it try to represent the real world. Okay, so it will be much after a few years of development, it will be more real. And if people trying to use it, then of course it will be more popular. Okay, then the last one, we have this thing called semi-structured data model. Okay, so when this online shopping become more and more active, then this semi-structured data model will become more famous. Okay, so we have this thing here, the structured data represented in a strict format. So you can see we have this, it is already fixed, okay, a strict format. But sometimes this data that we're going to collect, it may be follow the same standard. So just now we mentioned for the OO part, we want to keep track of this testing result. Sometimes we only can keep check whether it's pass or fail. But what is the process, the time of process or the data of the process from the starting until the end? A lot of time, the testing is only failed during the last few seconds or last few minutes, but we cannot say that the test is really failed. Okay, so that's why a lot of these scientists start checking actually which part of the test is failed, then it caused the whole testing wrong or whatever. Okay, so they try to do it this way. They use this thing called semi-structured data. It has a certain structure here, so the structure may not be so rigid, so fixed. It can be more complete, or whatever they want to put in. They try to use it this way. So we have an example here. When we need to use this semi-structured data, we have this scientific data and e-catalog as well. So let's say for this scientific data, we have this astronomers, something that captures out from outer space. Okay, so if all this out when we receive, it is hardly to determine whether there is any human being or any thing actually speak or something. Okay, so the scientists always try to do this. They have a lot of time. They try to check through whether there is any sound rather than just a wind or any other thing. So they check whether actually there is any human being or any knowledgeable any knowledgeable object that actually stop or speak something. Okay, so this one is the reason of using this scientific data. They receive a lot of this noise or voice or any of this data from the outer space. So after some time, they need to do some analysis, see whether anything is inside or not. So this one, they need to use this thing called semi-structured data. Anything that is the same, they will just put into one database. Then maybe another thing that it seems like not the same, then they put into another database. Okay, so this one is something that can be used when we have a thing called semi-structured data. We also have some example here for the e-catalog. Okay, you can see from here we have this thing called transparent sticky tag, magic tag, or traceless, washable, accessible, double-side, reusable, clear, sticky power tag. So many things, but it's just used to describe the power tag. Okay, so if anything or any of the keyword is actually a key in when you want to search something from, let's say, Shopee or Taobao or Lazada, any of the keyword that you key in, of course, including this power tag, then this result may be shown. Okay, so this seller is actually quite clever. They use all the keywords here in order to attract or in order to force the system to show this result to the customer. Okay, so actually there is no sorry. Okay, actually the keywords here, it seems like too much, but it all used to describe this power tag. So it is somehow semi structure. So the first part here is the description, but the last part here, the power tag, is actually the object. Okay, so this one is one sample of using this semi structure data. We also have another example here, also a cut paste. This one don't have any. Let's use it as a sample. So you can see we in let's say Lazada, Taobao, or even any of these online sales, we have a lot of items here. But all the items, when they are doing the description or they want to show the picture, show the price, other than price, what is the similarity? Actually, from one to another, there is no such thing called similarity. So let's say this one is 1 kg, but this one is 500 grams. Why they don't use the same measurement to describe? Because it's hardly let's say we have something like liquid, then it may be in liters, okay, it may be in ml, but not kg or gram. Okay, so the measurement that used to measure this object and another object, product and product, it is different. So it may be using this semi or structure data. So whatever that you want to describe, we just put it in. Then we will try to list out anything that is already there. So let's say for measurement of kg or ton, maybe if you have the record inside, we will just the Lazada or the Shopee will just try to show it to the customer. But sometimes, let's say this one, the hardware part, compared to the food, of course, the description will also different. So this one, you may need to mention the volume of this dust keep inside, how large is it? Otherwise, after you use it sometime, maybe less than 20 minutes, it's already full. And how? Okay, so this part, they need to describe something to the user, or to the customer, the power or the power that's sucking all this dust to the box here. What is the power? Okay, so this one, the description will somehow different from all other products, let's say food and this others. Okay, so this may or can suggest to use this semi-structured data. Okay, so the last part here, we have this unstructured data. Okay, so the problem come out here. We have this thing called unstructured data. So structured data for us, for the database developer, structured data will be better. We do not need to bother too much. We already know all the fields here, and we just continue. And we try to set the integrity part as well. So this one is the structured data. But for my semi-structured, somehow here, some of the field we may not have the ability, or we try not to do the setting of security or integrity or whatever. So just to let the user key in whatever that they want to key in, and try to represent the whole thing to the user or to the customer. For this unstructured data, the problem here is we not even know what's the thing that want to key in, but we try to set the field, all the field, we just give the name and whatever that you want to put in. It is up to you. Okay, so very limited indication of the type of the data. So let's say name, of course, need to be there. Okay, then I continue. If I let's take this online sales as example, then maybe price need to be there. But you can see from our sample here. Today I may sell this thing at $9.90. Tomorrow I may change it to, let's say, only $5. Okay, so this one is something it keeps changing. So the data may not be able to do the restriction or to set the integrity. Okay, another part here is that the text document is the web page containing maps, image, sound, and this video segment. Okay, so when you click a list of product, vacuum cleaner, right? Okay, so when you click a list of products, you can see, you may be able to see some of the image, some of the video as well. Then how are we going to store this? Of course, can, no problem. But when it compared to all others, some of this not even have a video, not even have so the data that compare one product to another is totally different. Okay, so that is the reason why we want to use other type rather than the structured data. Okay, so the reason to use this unstructured data, very limit indication of the type. Okay, so we not even need to know, we do not know what is the user want to key in to this field. Okay, so this one is we have a little knowledge about what the data type should be put. And we have some of this text document or whatever that are used to describe all the product here. It may want to put it in, it may not want to put it in. So this one is hardly to judge whether this field need to be used or not. Okay, so okay, so we end this one. Okay, so we give some more example of this semi-structured data. So you can see here we have two things. One is the LCD TV, one is the projector. Although both of these things is still used to, let's say, watch movie or try to show the show or try to do some kind of communication, let's say Google Plus or whatever. Okay, so the model you can see here, both also have a model, also have the brain here. But start from here, the series for LCD, we have a series, but this one it didn't have. And then the main part here for the display, this one is totally not the same. So this one is for the LCD TV. This one is the screen size. But for this, there's no screen size. Totally, there's no screen size here. Okay. So it may show you how big. Is it? Okay. How big this ratio can be shown to the viewer. We have a 16 and 9 here, so it's quite similar to previously. Okay. So the screen size is totally not there. And for this projector, you have a special part here, the lamp and the length here. Okay. So how bright is this projector? And how many working hours it predict how many working hours you can use to. So let's say we have 3,500 hours normally used. We can use up to this time. Okay, so you can see from this semi-structured data here, some parts it may be the same, but some it may totally different. So a lot like what we mentioned just now for the product that lists in the online shopping price, the name should be there. Other than that, it seems like one compared to another, it may be different or it may be totally different. Okay, so this one is the comparison of using this LCD and the projector. So this kind of product, and of course, we can use this semi-structured data model. Okay, we also have another example here. Okay, so if you have this, if you watch this IMDb previously, you can just try to show. You just type one movie and then do the comparison. Search another movie. So see what is the thing that actually show to you. The description sometimes is different. Okay, so the internet movie database. So this one showing the database about the internet movie is a classical example of collecting this semi-structured data. So this one we already mentioned for the LCD TV and the projector. Some part is the same, some part is totally different. Okay, but it is the same. It is the movie. Why we want to use this semi-structured data model? Do you think one movie, the description of one movie can be totally different from others? Okay, so although the information pretending to different movie may essentially similar, so you can see the keyword here essentially similar. So I think it should be similar. Why you can say this one is different? But sometimes the structure may be different. Okay, so we just go through and see. We have this irregularity in the structure. So for the IMDb, we have two kinds of show here. One is the movie, one is the TV show. Okay. Although you type the keyword to search this movie, whether it belongs to movie or it belongs to the TV show, yeah, it's different. But for this example, we only take movie as an example. Okay, we only take movie as an example. So some movie may annotate information about the actors, director, producer, but sometimes some of the movie may also include this writer and the music director as well. But the previous one didn't have this music director. They not even want to put this music director inside. Okay, so you can see from here we have this actor, so cast, director. Oh, for movie one there is no actor. Okay, so we have this example. Let's say the real movie and some of the cartoons. For cartoon there is no actor. Okay, so that's why although it is both also a movie, but the field inside here, the structure is totally different. Okay, so I'm not say totally different, but it is not in a good structure. Both movie won't have the same structure when you are search this IMDb. Okay, so how? Okay, our question here is how did IMDb actually structure their field or their entity in order to show this when you are search? Okay, when you search internet with IMDb, how they actually save all this data to the computer, to their database. Okay, for example of this one here is the actor name may have, okay, one of the actor name. This one is keyed in by the user. A lot of times they just show this IMDb database, but next time when the director or the person in charge for one movie want to key in the data to the IMDb database, this one is based on their own method of key in. So you can see from here the actor name may be represented as only one string. So let's say Alvin Lim, Zhi Yong. So one straightforward one string name. Okay, but sometimes they may just put it into pivot. So this one, the first name, second name, last name. Okay, so this one is totally different. So all those we have this actor name as one field, but sometimes the data key into the IMDb is different. Okay, so when data are added to the database dynamically, the structure of the database as a whole also keep changing. So when the user key or the person in charge of key in, we are the user, if we search this IMDb, but the person who in charge to key in the data for one movie and another, sometimes it's different. Okay, so when the data add to the database dynamically, the structure of the database will keep changing. Okay, so you can see from here, all those one movie, the field here may continue to extend, or for one movie, maybe only a field is actually a key into the database. Then they only show some, but not show all others as well. Okay, so based on the data key in, it is somehow different. Okay, so in order to do this, we need to use some method. So I think previously, if you learn web development before, you should see this keyword called SML. Okay, so for this SML, it does try to list out something. Okay, list out something. The structure of this from one product to another product is totally different. Okay, so for this part, you want to say product number one, the name is Zoom X, then the price is $10. Okay, so this part and this part, it may be totally different. Okay, it may totally different. So we not even need to build one database, but we just keep all this data, and the user will need to key in something, and they need to decide what is the field name that they want to key in. Okay, so for our example here, when they key in this first name, then they need to describe in the field type, field name say, okay, this one is actually the first name, this one actually is the last name, or if some of the actor or some of the director have a middle name, then they need to key in as well. Okay, so this one is based on the user key in. Okay, so I think we will eventually have this thing called distance and SML. We try to develop this thing to reflect the learning part of this ADM. Here we have this semi structured data model. Okay, we have some examples here for this distance data stream. Okay, we try to show this thing as okay as if we go open this using our web page web browser, we can actually see this one as one database. Okay, so we have a one ID here, name, price, tag. Some of this part, when we see tag, some of this part, we can have any other thing. Okay, and stock is warehouse or retail, what's the pricing. Okay, so this one is something, and you can see we have got this. Sorry, I missed out my part here. Minimum. Okay. Okay. The explanation for this part. Okay. For this part, it seems like it is required. The first part here is required. Start from the tag part here. Some of the product or some other product, this part may not always need to include. Okay, so this one is my explanation. If we have this SML, we try to use this to show to the user. But the first part here, it seems like it's an important part. So when we do a comparison, we may use this one to do compare. But during the explanation or during the description, then this part it may or may not need to include. Okay, so this one is some fixing and some other thing that is different. So this is a data stream. The streamer define that this one is the fixed thing that you need to input. Whereas go through the validation, go through the documentation, and use this hyperlink and navigation. So this one is some kind of how to say. Okay, you should be saying this way. Okay, so this is a JSON data stream. So that's how I already mentioned. First part here, it may define it as a required. Second part here, based on the product that whether it need or no, it may try to include or ignore. Okay, so this one is my explanation for the JSON data stream. So it try to write this schema. So when the user try to follow this stuff to populate to key in the data, then during this showing to the user part, it will have this one is the structure. So during key in, it will have this validation and some of the documentation. See which part, let's say the description is the documentation. So describe what is this field is about. Then if any of this need any of the linking, it will also include inside. So there is a one interaction between one to another. So let's say when I click this product, it actually help me to navigate to some other website as well. Okay, so this one is the JSON and JSON data schema setting or the definition of this part. We may have a time, I think during week 7. If not mistaken, after week 10 or week 11, we may have one section for this part. Okay, during that time, we only mentioned this again. Okay, then we continue to the last part. Here, okay, so the disadvantage of this model, so we have this thing called semi-structured data model. We know for our future development, a lot of the time, we actually develop in this way, so semi-structured data model. It has the advantage of us, it can represent the information for data source that cannot be constrained by the schema. So this time we already mentioned for our previous data model, we already set, let's say we already set the branch number, name, location. So the user must follow the structure and key in the data to the database. But during our actual life now, if we still based on the same structure, a lot of this data is hardly can be keyed in or hardly can be input in the database. So for this semi-structure, it actually can represent a lot of this data that is hardly can be classified. Okay, so let's say for one build, let's say from Lotus or from Aeon, even a one build, the field inside may be different. Okay, so if we want to use the structured data model, then it is hardly can fulfill the requirement. So it provides a flexible format for data exchange between the different data type of a database. So this schema can easily be changed. So based on this, if you see some field that is not included in the database yet, then you can always do the changing. So by changing this, it only affects the structure, but the whole database you can be worked through without any problem. Okay, so this one is the advantage of this semi-structured data model. But a lot of times, this part have an advantage, but it also have this disadvantage or inefficiency as well. So compared to the relational data, this one is actually the semi-structured data is actually quite inefficient. But this is a tab, which represent a similar information are repeated. So you can see from here, a lot of this tab is actually repeated. So sometimes for the programmer, they may need to go through a lot of time, then only you can see what is that. Okay, so this one is inefficient. Better than a relational as a data exchange format. Okay, so we just now already mentioned this for the semi-structured data model. We are actually using XML, and the method of using XML is something like this. So the compared to the relational one, this one is used as a data exchange format. So it can be used. This one, if you already define this one, then it can be used in almost any programming. Okay, so use it as a data exchange format. So any of the programming language actually can access this semi-structured data. Okay, unlike a relational attribute, SML and JSON data is just documenting due to the use of the tag. So you know, when you use it, you need to use all these tags to demo or to show to the customer. Non-rigid format, the tag can be non-digit format, the tag can be added in the screen, can easily be changed. So for this part, for the first one, we may use a price. Later, we may use another one. So sometimes this one is quite hardly to do the control. Also, it allows this connected structure. So after one tab, you may have another tab that is actually under the first tab. So the programmer may need some skill how you're going to list out all this. It is wide accessible, not only in the database system, but also in the browser. So during your web development class, the first time, okay, I only show this in one section. So we try to show this using a browser, and the code that try to type in, it seems like don't have any structure. Okay, but it can be used in almost currently almost at any part, and the programmer will make a way to read it and display to the user. Okay, so this one is the good point about this semi-structured data model and some of the limitations. So firstly, I think we already mentioned for SQL, no SQL, or even for this semi-structured data model, it actually need a lot of this processing power in order to go through one round of all this data they only show to the user. Okay, it somehow need more. Okay, need more resources. Okay, so to finish this data model, a lot of theory or the last part for the OO and for the semi-structured data model, or even the latest part we have this NoSQL, we only have the idea here. We not even try to use it yet. So we may try and see whether I can. Okay, so any question before we end? No? Okay, if no problem, then I mentioned this again. For Thursday practical class, you must get yourself prepared. I will change this you see the practical class submission. I need all the students to try first before actually attend the class. Okay, so when come to the class and say you haven't prepared yet, I need to do a comparison. What is the different? Okay, what is the material? What is the result that you can get and compare to the answer that I may provide. So try to submit before the class starts. To be one day before the class starts. Then I know what is the setting. Test. Okay, sorry, I might have some problem. Okay, so you must submit first. Okay, submit first, then only I can judge based on the level how much effort that you put into this subject. And you can ask. Okay, so I'll end here. And anything you want to ask, you can say and ask some questions. If no, then you can leave now. Please put a part one. Please put a part two. Then you can leave now.